Hi, this is Mrs. Bustamante. I'm going to try and walk you through some stoichiometry problems here. Bear with me. This is the first time I've really tried to record this, but we're going to do problems 3 right now from the Limiting Reactant Worksheet number 1. You'll notice I've wrote out some of the information that you kind of need to get started with. That'll keep you going and just speed up the video a little bit. Okay, so this reaction says consider the following, and it gives us silicon plus nitrogen makes trisilicon tetranitride. It says when 3 grams of silicon react with 2.8 grams of nitrogen, how many grams of trisilicon tetranitride are formed? So before I can even start this problem, I need to balance my equation. That's really important. I have to have a balanced chemical equation to be able to do this. So this is where you would do your atom inventory, figure out how many silicons you have on this side. You have 1 over there and 3 as a product. So I'd try a 3 here. And then when I look at nitrogen, I have 4 over here and 2 here. So 2 times 2 will give me 4, and then they'll be balanced. And over here, that means this is a 1. So now I'm going to look at my problem. I'm going to write out my given. In my problem, they gave me that I have 3.2 grams of silicon and I have 2.8 grams of nitrogen, and they want me to find how many grams of trisilicon tetranitride are formed. That means I'm moving from grams to grams, so it's a mass to mass problem or a grams to grams problem. And so I'm going to need the molar masses of all the reactants and all of the products. Remember, to find molar mass, you look at your periodic table and you multiply it by the number of atoms you have. So silicon's molar mass from our periodic table is just 28 grams per mole. Nitrogen's molar mass, because there's 2 of them, is 2 times 14 grams, which gives you 28 grams per mole. And trisilicon tetranitrides is 3 times the 28 for each silicon, plus the 4 particles of nitrogen that you have, times 14 grams, so that gives you 140 grams per mole. And they want to know how many grams I can make. So that means one of these 2 reactants is going to limit the reaction. It doesn't matter which one I start with first, just pick one. In my instance, I'm going to start with 3.2 grams of silicon just because it's there. So it's my given, so I'm going to go 3.2 grams of silicon. And I measure on my operating table because I have grams on top. I know I need grams on the bottom. This is my molar mass of silicon, so I put 28 grams of silicon. And that's how many grams are in 1 mole of silicon. So now I have converted my grams of silicon to moles of silicon. That's my first step. My next step is then to use my mole ratio for my balanced chemical equation. So I can take my moles of silicon and change it into moles of trisilicon tetranitride. So this is where I use my mole ratio. I have 3 moles of silicon in my balanced chemical equation, and then I get 1 mole of silicon, trisilicon tetranitride for every 3 moles. So I've gotten rid of my 1 mole of silicon nitride, and now I'm into moles of silicon nitride, but I want to get to grams. So I know the molar mass, 1 mole of silicon, trisilicon tetranitride has 140 grams, Si3N4. Okay, so I'm assuming you know the math, how to do the math here, right? 3.2 divided by 28, hit enter. You could multiply by 1, it'll give you the same thing. Divided by 3, hit enter, and multiplied by 140. That gave me an answer of 5.3 grams Si3N4. So I did half the problem. I need to do this again, but now I'm going to do the same thing starting with nitrogen. So this time I'm going to start with 2.8 grams of nitrogen. Since I have grams on top, I'm going to take my molar mass on the bottom, which we found was 28. That's how many grams were in 1 mole of nitrogen. Gram divided by gram cancels. My mole ratio is next. This time I have 2 moles of nitrogen for my balanced chemical equation. For every 1 mole of Si3 and 4. Okay, so moles of nitrogen are gone. I do my molar mass. And you'll notice the second half of the problem is the same in both steps, and it always should be. That's how you should know you're doing it correctly, because we're ending in the same substance. And here I got 7.0 grams Si3 and 4. So now I have to look at this question that says, what is the limiting reactant? So which one of these reactants made less product? And when I look at that, 5.3 is less than 7. So because 5.3 is less, that's what I got when I started with 3.2 grams of silicon. That means that silicon is your limiting reactant, the one that you'll run out of first. So rich reactant is an excess, and how many grams will be left over of the excess? So here's what I want to do. We know that N2 is in excess because silicon was our limiting reactant. So this time I'm going to start with how much product I actually can make, which we said was 5.3 grams of silicon, Si3N4. So that becomes my given, 5.3 grams Si3N4. And I'm going to convert it back to the reaction I had excess of. So now I'm going to start with that much product, convert it back to N2. That's going to tell me how much N2 I really needed in order to get 5.3 grams of trisilicon tetranitride. Okay, so this is the reverse of what you did. Now I'm going to put 140 grams Si3 and 4 on the bottom. That's how many grams I have in 1 mole. Okay, so grams cancel. I'm going to change moles of Si3 and 4 into moles of nitrogen. So I'm doing the opposite of what I did right here. This is still from my balanced chemical equation. So 1 mole Si3 and 4, and I change it into nitrogen, so I have 2 moles of N2. Cancel, and I'm going to change moles back into grams, so I know the molar mass of nitrogen, 1 mole of nitrogen is 28 grams. So moles of nitrogen cancel. That means I'll be left with grams of nitrogen. 5.3 divided by 140, hit enter, multiply by 2, hit enter, multiply by 28. That should give you 2.1 grams of nitrogen. Now what that really means is that's the amount of nitrogen that you need in order to make 5.3 grams of Si3N4. You don't need any more of that. So we want to know how much extra or leftover did we have. So to do that, all we do is take how much we started with. In actuality, they gave us 2.8 grams of N2, and we subtract how much we needed, 2.1 grams of N2. That means we have 0.70 grams of N2 excess. And that would be my answer. Always good to box my answers. I hope that was helpful.